Hi there, and thank you so much for your attention over about the next 20 minutes as we speak about invisible security at the speed of cloud. We've come a long way in terms of how we both develop software and the infrastructure underneath that powers it. If you have the same level of gray in your hair that I do, you may recall when we ran workloads on physical servers in a 1-to-1 ratio. It's no wonder we built big monolithic applications in this era, as procuring new infrastructure could easily take 6 months or more. As our infrastructure became a lot more agile via virtualization, we began to take advantage of that and build applications in a much more agile and dynamic fashion. Today we make use of the public cloud platforms that come with an assumption of near infinite scale and instant on. Infrastructure is no longer the barrier. And so to move as fast as we can, we need a marriage between developers who author the software and infrastructure who deploy it. In modern data center environments, developers write software and are responsible for such and all the required dependencies. Security plays a large role across 3 vectors: workloads, including base virtual machines and sometimes containers; the network, security of perimeter firewalls and hosts; and of a container orchestration engine, usually Kubernetes. In cloud environments, developers are tasked to author software much faster, since infrastructure is no longer a barrier at all, and are still responsible for that software and all the required dependencies. Even though security gets to offload one vector of concern, if you will, in the security of Kubernetes to their cloud service provider, any advantages that may provide are seemingly offset by the fact that security has the impossible job of getting eyes on every single workload that exists in a given cloud estate. Never mind doing so for workloads coming through the software development pipeline that haven't been deployed yet. What inevitably happens is security winds up being a bottleneck, and developers begin to get frustrated. Security are completely overwhelmed with all the areas of focus in production: cloud workload security, IAM right sizing, network architecture as it relates to containing the blast radius around your critical services and data, cloud security posture management, and the list goes on before we even get to measuring risk in software development pipelines. It's easy and understandable for developers to feel like security is simply making their jobs harder, while on the flip side, security analysts feel like they're powerless to actually carry out their mandate of full coverage. So it's important to consider how we bring security to the table as early or as left as we can in our software publishing process. If we don't, we risk alienating developers from security policy even more. If we feed back to our developers that there are risks in their applications or configurations only at the very end of the process, we're wasting their time. Our goal is to find a way to measure risk as early and, just as important, as unobtrusively as we can, and feed that back in real time to development. Perhaps it's a supporting open source library required by an application that has software vulnerabilities. Let's get that information into the hands of the developer in a way that is familiar, such that they can correct the problem quickly. So that really sets the stage for our goal as DevOps, or even as DevSecOps teams, to reduce the friction between software development and operations and security. Let's talk about that from a tooling perspective. So let's consider how we do this today with workload agents. Agents are installed and maintained as another application that run alongside your custom-built workloads. Agents provide visibility into what's running on each host. The problem with agents is that you're required to install, maintain, and upgrade them, which essentially means you must apply the same software lifecycle as you would to your mission-critical applications. When you don't treat them with that level of vigor, your workloads effectively become invisible and orphaned, which is a real challenge from a security perspective. Unsupervised workloads are a little bit like unsupervised children. They find ways to get in trouble. Another approach that's been used in the past is the network scan. Network scanners probe resources externally, looking for known configuration errors. And these two solutions have really been the cornerstone of host security for many years. If you wanted to understand your physical security posture, for example, you were required to use one or both of these techniques. And in fact, we still use these today, even in the very modern public cloud environments. Where agents used to run on physical machines, they now run on virtual machines. And scanners are now deployed as appliances in virtual networks. Over the last 5 or 6 years, a third category of security application for the cloud was added called CSPM, or Cloud Security Posture Managers. Their purpose is to monitor the cloud configuration itself. CSPMs connect to cloud service providers and analyze the security configuration of services you use like virtual machines, networks, storage buckets, and more. Although CSPMs provide visibility into the security configuration of cloud resources, they must rely on legacy agent-based solutions to peer inside those workload resources and measure risk. There are two main problems with these approaches. The first is that agent deployments do not scale. On average, we have seen that less than 50% of all cloud assets are covered by all the security solutions an organization leverages, including agents. The reason for this is that it's just about impossible to deploy agents everywhere because of the massive inter-organizational friction that happens when you try to get agents deployed universally, even in organizations that have dedicated functions or teams. And this is very applicable to our DevOps enablement theme we began with early in our presentation. When we demand any organization or team, but especially software developers, to install security agents along with agents for performance, backup and DRP, and many other disciplines, we are placing both the burden and our complete dependency on them for doing this correctly, every single time. It's a process fraught with problems right from the start. Even if we can find a way to solve for that, the second major problem is that there are simply too many security alerts. Once we find a way to feed back security risk information to our developers, we face one more problem: getting them the information they need to be successful. No more and no less. We found that on average, organizations will discover about 10,000 vulnerability alerts for every 100 assets. One key reason for this is that organizations are using multiple tools that only work in their respective silos. They don't understand the overall picture and how security controls relate to one another. With an agent-based approach, the onus and responsibility of adding the necessary context to these tens of thousands of alerts once again falls on the security team. The complexity of this grows exponentially when you also consider that these teams are typically responsible for managing tens or hundreds of cloud accounts across thousands of resources. It's simply not feasible. If security professionals are overwhelmed, what do we expect developers to do with this tidal wave of information? Our friends at SC Media have conducted research that was surveyed at RSA 2018 and told us that most enterprise IT efforts see more than 10,000 alerts every day. Over a quarter of enterprise security teams see more than 1 million alerts a day. If we truly had that many noteworthy issues or security controls to verify, that would be one thing. But Critical Start in some similar survey efforts found that the majority of security professionals stated that over half of these alerts are false positives. Those teams tasked with analyzing and acting on these alerts are clearly tuning out by absolute necessity. With that many alerts, the severity score need not even exist. There'll never be an opportunity to address anything but the most severe, and your chances of getting through all of them are next to impossible. What's more is that the sources of noisy alerts will get turned off or tuned down, and then you risk missing important and meaningful alerts in the sea of them all, which can lead to disaster, as we learned about in 2014. Back in 2013, a data breach happened with a retailer making the shift to online transacting that exposed 40 million customer credit card details, among other things. Much like we've already spoken about, its security team had actually received alerts about the presence of malware on the network from a threat detection tool. But the overburdened team chose to ignore the alerts because they were so common, the famous boy who cried wolf sort of scenario. Well, by now you know the rest of the story. The retailer is still paying customers who are victims of the data breach. This slide attempts to convey a few different ideas, so let's spend some time here and break this down. In terms of cloud security, we have two different categories of security tools and capabilities. First, Cloud Workload Protection Platforms, or CWPP, that measure workload-specific risks like software vulnerabilities, malware, and host or container-based misconfigurations. Then, to measure the state of your cloud security controls and compare them to either formal standards or best practices, we rely on Cloud Security Posture Managers, or CSPMs. Both are required for a holistic approach to cloud security, and both have distinct limitations in how they consider and score risk. Don't worry about straining your eyes for each example. On the next slide, we'll blow them up and dig a bit deeper. On the left, we have the types of resources we consume from public cloud providers, and you'll notice that applications straddle the line between CWPP and CSPM. If you are leveraging instances and containers for your application, you require a host-based CWPP approach. But if that same application leverages serverless functions like Lambda or database as a service offerings, for example, you will also require CSPM capabilities to ensure your security controls associated with each of those services are configured properly and do not change. With each different cloud security approach, we have significant challenges and limitations regarding how risk is calculated. Diving a bit deeper into the examples, let's tackle cloud workload protection platforms first. The challenges here are many, but let's focus on the top two. The first is that the default practice that just about every solution in this space follows is to adopt the CVSS score of a discovered software vulnerability as the absolute risk score without any consideration of the environment around the workload where the vulnerability was discovered. The second is that because CWPP platforms integrate per asset, meaning that they install workload agents in each instance, their ability to understand context of what is around each workload in terms of cloud services, even the firewalls that govern access in and out of them, is extremely limited. Shifting to CSPMs, we find that risk is hard to judge accurately with only a perspective on security controls, but not the data that lies underneath them. CSPMs ask questions of cloud service provider APIs. So questions like the state of S3 security controls or identity and access management policies like multi-factor authentication, use of for cloud users, not users logging into services provided by instances or containers. They do not understand the data inside of those storage buckets, however, for example. And that means that a mismatch between security controls and data sensitivity is always possible. It also means that severity is relative, and the top alert about default security groups is ranked as the highest severity, even though resolving this for me will do nothing to my overall security posture, as those groups are in regions that I simply don't use. To be clear, it isn't worthless information, and there is something I can do to reduce the risk of these security groups being reused and assigned to workloads in the future. But this sort of alert should never take precedence over something that is directly actionable and can make a tangible difference in my overall security posture. This is how we get into the problem of an overwhelming amount of alerts, all of the highest severity. It's for this reason of siloed perspective, among others, that Gartner has predicted that CWPP and CSPM solutions will merge into single solutions and offerings, and we've seen that begin to happen with single vendors acquiring capabilities in both of these areas. But we still have a long way to go. So the largest contributing factor to this phenomenon of alerts gone wild, if you will, is that the vast majority of approaches to the challenge of cloud security only consider one dimension of risk, the severity of the underlying security issue. This invariably ends up treating your cloud as a long list of alerts that lack context, causing that dreaded alert fatigue and ultimately leaving you exposed. But risk is much more than the severity of the underlying security issue. It's much more three-dimensional, if you will. Risk involves not only the severity of the underlying security issue, but also its exposure, who has access to take advantage of that issue, and what is the blast radius? What is the potential impact to the business? So if we think of risk pragmatically as this potent three-way mixture of external risk indicators like the CVSS score of a software vulnerability, the exposure associated with the detected risk and therefore its likelihood to be exploited, and just what that risk can touch or has access to if exploited, we've got a much more accurate view of just how severe any given risk truly is. We hear a lot about machine learning and artificial intelligence to learn and point out anomalies in user behavior and service consumption across the public cloud. While some inference based on previous patterns can be useful, it can also significantly add to the false positive noise when it's wrong. And that's the whole phenomenon we're trying to solve for. ML and AI certainly have their place in predictive analysis, but leaving the consideration of context on the table is a massive mistake, as it is our best means to separate what is truly important and needs action now versus what can wait. So let's do a very small exercise to better illustrate how context can help a drowning security operations team. If you consider server 1 and server 2, You can see that they are both running a web server that uses a vulnerable library, vulnerable to remote execution risk for the sake of this example. And as you can see, the vulnerability in both cases is exactly the same and carries a high CVSS score. A contextless approach to the problem would simply report this vulnerability with a static CVE score, and both workloads will end up getting the exact same score, which means the exact same risk categorization, which means the exact same amount of time will be spent on each of these alerts. That is to say, if they get acted upon at all, imagine hundreds and thousands of the highest severity alerts every day. What if, however, we considered more than the CVSS score? If we consider the environment in which the risk was found, we can tell that the service on server 1 is internet facing, and therefore the risk is classified as imminent compromise. Whereas server 2 is not internet facing and can't be reached directly from anywhere but a single other host. So therefore the risk level has been downgraded down to a medium. This isn't to say that it's not important, but it clearly should not carry the same weight or risk level as the workload with the CVE that is public facing. This is a very basic example, but it serves to illustrate the point that context is absolutely mandatory in any security strategy. With thousands and thousands of alerts, you need to know which ones, if not addressed, would likely lead to compromise and would require action now versus those that can be more informational and can wait. So just before I let you go, a quick mention about the work we're doing at Orca Security, where we've purpose-built a cloud security platform that discovers both workload and cloud risks, and in fact uses observations from either side to inform risks in the other. For example, when Orca finds software vulnerabilities on a host, and as we reviewed in our high-level example, a number of contextual factors are considered, like cloud network accessibility, age of the vulnerabilities, known exploitation paths, and more. All of that information is used to score each alert, reducing the many to the important few. Orca is agentless and deploys across your cloud accounts once instead of having to install and maintain an agent inside of each workload, and provides deep intelligence about configuration, misplaced sensitive data like PII, indicators of lateral movement, malware, and much more. We'd love to get a chance to show you more. And that's it. Thank you so much for your time.